Welcome to The Explainer. Today, we are putting on our detective hats to solve a business mystery that costs companies billions of dollars. And the crime? Well, it's making massive bets based on data that isn't just wrong, it's actively trying to mislead you.
Okay, so let's open the case file on this one. For years, a company like eBay, a super data-savvy company, poured millions into Google Ads for its own brand name. And internally, the data looked amazing, a huge return on investment. People who clicked the ads, they were buying stuff at a fantastic rate. But here's the twist. That entire analysis was completely fundamentally flawed.
You see, they fell into one of the oldest, most classic traps in the book. They confused correlation with causation. I mean, think about it for a second. Who searches for the word eBay on Google? People who already want to go to eBay. The ad click was strongly correlated with the purchase, sure, but it didn't cause the purchase. The customer's intent to buy was already there. So what's the real difference between these two big ideas?
This really breaks it down perfectly. Correlation is just an association, two things that happen to be moving together. It's like a two-way street. Causation, though, that's a one-way street. X directly causes Y. For eBay, the customer's intent to shop was the real cause. That intent made them both search for eBay and make a purchase. The ad, it was just along for the ride.
Now, this confusion isn't just a simple mistake. It's a really fundamental problem in data analysis. It actually has a technical name, and it's the secret villain behind so many failed strategies and millions, if not billions, in wasted money.
So, this hidden culprit, its official name is endogeneity. Now I know, it sounds super complex and academic, but the concept is actually pretty simple. It's what happens when the thing you think is the cause is secretly tangled up with the real cause. It's like your data gets contaminated, making it impossible to see the true impact of any one thing.
And here's the really crucial point. This isn't some small rounding error. Endogeneity doesn't just nudge your results a little bit. It completely invalidates your analysis. It doesn't matter how much big data you have. If endogeneity is present, your results are going to be biased and totally misleading. You'll just have a very precisely calculated but completely wrong answer.
So how does this culprit, endogeneity, actually commit its crimes? Well, it has a few common methods of operation. And as causal detectives, we need to learn how to spot them. Think of them as the 5 usual suspects. Here is our lineup. We've got omitted variable bias, reverse causality, simultaneity, measurement error, and sample selection bias. Let's break down each of their tactics with a really simple example so you can start spotting them out in the wild.
First up, omitted variable bias. This is the classic firefighter problem. If you look at the data, the more firefighters show up to a fire, the more property damage there is. But of course, the firefighters don't cause the damage. The omitted variable, the thing you're not seeing, is the size of the fire. A bigger fire causes both more firefighters to show up and more damage. This is exactly what happened to eBay. Their omitted variable was the customer's intent.
Next on the list is reverse causality. This one is pretty straightforward. It's when you have the cause and effect completely backward. A company's board might approve a huge pay package for a CEO hoping it'll drive better performance. But let's be real. In reality, it's almost always great past performance that leads to the big paycheck. The arrow of causality is pointing in the exact opposite direction.
Third, we have simultaneity. Now this one's a tricky little feedback loop where two things are influencing each other at the exact same time. The classic example is price and demand. A lower price definitely increases demand. But a huge surge in demand is also going to cause sellers to raise the price, right? It's a chicken and egg problem, and it's happening all at once.
Okay, suspect number 4 is measurement error. This is basically when your tool for collecting data is broken. So imagine you have a sky-high customer satisfaction score. Looks great on a chart, right? But what if you're only surveying the customers who are already happy? Or what if you're asking about vague intentions instead of actual concrete behavior? You end up chasing a number that doesn't really predict anything.
And our final suspect, sample selection bias. Oh man, this one is a huge one in the business world. It's when the group you're studying isn't representative of the whole picture at all. Think about all those business books that study only hyper-successful companies. They find these common traits, but what they're ignoring is the thousands of failed companies that did the exact same things. You're only looking at the lucky survivors.
All right, so we've identified the suspects, and we know their methods. How do we fight back? What's in our detective toolkit to actually uncover the real cause and effect?
Well, the most powerful weapon in our arsenal, the absolute gold standard for proving causation, is the randomized controlled trial. Now, in the business world, you probably know this by a much more common name, A/B testing.
The logic here is beautifully simple. First, you're randomly, and that word is key, you randomly split your audience into two groups. The control group gets the normal experience, while the treatment group gets whatever new thing you're testing. That random split is so important because it ensures the groups are pretty much identical on average in every other way, from their motivation to where they live, you name it.
And that is the magic of A/B testing. That randomization, it just snaps the link to all those other tangled up factors we talked about. It neutralizes our 5 suspects by its very design. So now, any difference you see in the results has to be because of the one single thing you changed. It is the cleanest, most direct way to prove cause and effect.
So, how can you start using this detective mindset in your day-to-day work? It's not about learning how to run complex statistical models. It's really about developing a new instinct for questioning the data that you see every day. To be a good detective, you have to recognize the warning signs. So listen for these kinds of phrases in your next meeting. Things like, well, companies that do X are way more successful. Or, our best customers all came from this one channel. These are massive red flags. They signal that a causal claim is probably built on some shaky ground, and that's when your detective instincts should really kick in.
And that's really the big takeaway here. Your most powerful tool isn't a complex piece of software, it's just a simple, skeptical question. Now that you know about our 5 suspects, just asking, could there be another explanation, is the one thing that can stop your company from falling into the exact same traps as giants like eBay. In the end, having more data doesn't magically solve this problem. In fact, these massive data sets can give us a really dangerous sense of false confidence. We can get a very, very precise measurement of a very, very wrong number. So the real skill for the future isn't just about finding patterns in the data, it's about having the wisdom to ask if those patterns reveal a true cause, or if they're just a beautiful illusion.